Today I'll be starting with chapter number 14, new chapter. The name of the chapter is Volume and Surface Area of Prisms and Cylinders. And today, day one, we will be going through the basic introduction of what is volume, what is surface area, their relative formulas for cube and cuboid, and the conversions of meter square to centimeter square, liter to milliliter, and so on. We will be discussing the important formulas over here from chapter 14a, and then we will be proceeding with the questions. After that, we will be discussing the introduction of 14b, the relative formulas, and so on. So let's begin. First of all, let us recall what were the areas. You all must have studied in the previous grade that areas are the shape enclosed by the straight lines, just like these two shapes. One is square on the left hand side, and the right hand side it is a rectangle. What was the basic difference between these two shapes? That all the sides were equal. It is known as square, and if two sides are different, then it was rectangle. It has width and length. These type of shapes were two-dimensional shapes. It has two dimensions, just like width and length, two different dimensions. Here you can see that this is side and side, both same, but this is the length and this is the width. But the thing is, they do not possess any depth or height, the third dimension. In volume and surface area, we will be strictly talking about the shapes which have depth or the height. And to recall their formulas, I have noted this: the area of the square is s square, and the area of the rectangle is length into width. So what were the areas? The area was the enclosed space in this, the area between these length, these straight lines. This is the area. If I talk about multiple areas, I will add those areas to get the total area of the shape. Let's talk about a shape in 3 dimensions. This is the box. To be very specific, this is a cuboid. This shape is known as cuboid. The difference between cube and cuboid would be discussed a bit later. But this box shaped, I have opened this box, and I have got these rectangle sides from this box. This box. So this is a small rectangle. This is also a small rectangle, and these are the 4 larger rectangles. But this complete join up to form this box. This is cuboid. So if I want to find surface area of this cuboid, I will find the area of this rectangle A1, this 2, 3, 4, 5, 6, and I will add them up to obtain the surface area of this complete shape. That means all the faces, this face 1, this 2 face, the top one, the bottom one, the front towards you, and the back face, all the faces, we will find the areas of all the faces and add them up to obtain the surface area. So let us read the definition. Surface area, also known as total surface area, is the sum of the areas of all faces of the object. And the unit, of course, the unit of surface area has a square in it. The examples are meter square, centimeter square, millimeter square, and so on. But all the units has squares with them. Let's proceed further. If I talk about these faces, these 6 faces, and I add them up, join them up to form a complete box, the space occupied by this box, the internal space occupied by this box, is known as volume. So here is the definition of the volume: the amount of space occupied by an object is known as volume. The unit of the volume has cube with it, that is meter cube, centimeter cube, millimeter cube, and so on. So here comes a shape. It has width, length, and height as well. It can be called as depth or the height, but the difference between the area and the volume is that the area didn't had the height, but now these three-dimensional shape, it has length, width, and height, 3 dimensions. So, and the volume is the internal space of this object. If I talk about what are the differences between, why do we need to calculate the volume and the surface area? What are the basic necessities to calculate them? Just giving an example, if I have this box and I need to color this part of the box, so I can calculate the area of this particular face and color this up, and I can calculate how much area I have painted or how much color I require to paint this particular face, or if I need to color whole of the box, so I can calculate all the areas and sum them up to find which is surface area. But when I talk about the internal space, if I need to if I need to put something in this box, let's say it is a water tank and I need to pour water in it. So how much water this box can contain, I can find it in terms of volume. So the internal space was known as volume. So this is the basic fundamental need to calculate surface area and volume. Now let's move further. Talking about cube and cuboid, exercise 14a consists of strictly two shapes, that is cube and cuboid. So this is a cube. It has all length, breadth, and height, all dimensions as a same value. It is I have named it A, and A. You can also name it S, side multiplied by side multiplied by side. You can call them sides or any specific alphabet, but they all are equal. That is important. And in cuboid, the length, width, and height, they are different. It can be width and length can be same and height can be different. If one of the quantity is different, we will consider it a cuboid. So the volume, the formula for calculating the volume is of a cube is A multiplied by A multiplied by A. That means we will multiply all these quantities which are same in case of cube, and it will be A cube. So we will cube the number we have here. Let's say if I say that the length of the cube is 10, find the volume of the cube. So I can simply cube the number 10 and I can obtain a number which is 1000. And I have shown this opened box here in terms of net. I have opened this as I have shown you earlier. So these are the 6 faces. So I need to calculate all the 6 areas and I need to add them up. In order to do that, I have a short formula for it, that is 6a squared. How this formula comes up? Looking at these nets, this is a cube. That means all the dimensions are equal. This length, breadth, and all the boxes have the same dimensions as I stated earlier. So I can calculate the area of this box, that is A multiplied by A square. Here also A square, A square, A square, and all 6 boxes are A square. And I add them up to obtain 6A square. This is the total surface area. But when I talk about cuboid, it has all the 3 different dimensions, or maybe 2 same and 1 different dimension. But in order to calculate the volume, I will use the formula length multiplied by breadth into height. All the 3 dimensions multiplied with each other to obtain the volume. I have opened this up cuboid as well. As we know that all the dimensions are not equal in cuboid as it was in cube. So I need to calculate the area of all the shapes, all the rectangles, 1, 2, 3, 4, 5, uh, sorry, 6, all the 6 sides, and I will need to add them up to obtain the surface area. But there's a formula derived, that is 2 multiplied by 2 bracket length multiplied by breadth plus breadth multiplied by height plus length multiplied by height. And these all first solved, then multiplied by 2, we will obtain the total surface area. So these are the basic formulas for calculating volume and surface area of cube and cuboid, which will be covered in 14a. Other than this, there are a few things like conversion units. Why conversion is important and why we need to know the conversions. As I've stated earlier in my example, that the volume we calculate like a tank, a water tank. If I need to calculate how much liter of water it can obtain, I need to calculate in centimeters or meters the dimensions, and then need to convert them into liters to know exactly how much water it can obtain, as the water and other liquids are calculated in liters and milliliters. So the conversion is 1 milliliter is equals to 1 centimeter cube, and 1 liter is 1000 milliliters or 1000 cm cube, as they are equal, and 1000 liter is 1 meter cube. 1 meter cube is 1 and 6 zeros centimeter cube. 1 centimeter cube is 1000 millimeter cube. Now, if we need to convert the units, let me first write it down for you, that the liters, the L stands for the liters, the ml stands for the milliliters, centimeter cube for cubic centimeter, that is exact name, that cubic centimeter, and meter cube stands for cubic meters. Now talking about how to convert, just the basic things I'm telling you right now, and when we will be discussing the questions, then we will be getting much familiar with how to convert them. That to calculate, to convert smaller unit to the bigger unit, we need to divide the value, and to convert the bigger unit to smaller unit, we need to multiply the value. So these two things are very much important to be remembered, not only for this conversion of meters and centimeters and liters and milliliters. Other than this, whenever you are converting anything, any two units, when we are converting smaller unit to a bigger unit, we need to divide the value. We will be discussing questions to make these two statements much understandable, but for now you need to learn these conversions, two fundamental important things, and the formulas of cuboid, of volume and surface area. That is very much important to be learned. So we are up for the lectures today, and do copy this down in your notebooks. Thank you everyone.